When we play with Legos, we can build anything. The Lego blocks are perfect modules for building stuff. Functions and software are similar to these Lego blocks. When we piece them together in certain ways, we can create something new. But how can we do it? How do we get started in writing modular code? My name is Heidi Seibold, and I'm a trainer and consultant for open and reproducible data science. I help researchers make their work more open and more reproducible in order to improve the trustworthiness of science.
Hi, my name is Russ Daniel. I'm an emerging technology leader within IBM Research. Today I'd like to talk to you about fully homomorphic encryption.
I am Arturo González Izquierdo. I am a researcher in electronic health data at the UCL Institute of Health Informatics. In this video, I am going to illustrate with an example the main stages in the development and implementation of a phenotyping algorithm.
My name is Piers Keane, and I'm a consultant ophthalmologist at Moorfields Eye Hospital in London, and I'm also a professor of artificial medical intelligence at the Institute of Ophthalmology at University College London.
One of the most common strategic decisions for digital health companies is which market to enter first with their medical device: the United Kingdom, the European Union, or the United States.
If you want to have a system where we learn quickly, where we have research and science informing guidelines and making care better in a reasonable timescale, learning health systems are the best way to do it, but they require IT and data infrastructure and training to be in place to do that.
Socio-technical factors refer to both the technical and the social, human and organizational factors that can affect health information systems in either a positive or negative way.
In this video, I will share with you what the lack of reproducibility has to do with research waste and how simple reproducible research practices can help you in becoming a better researcher.
In today's world, data is king. Researchers collect large amounts of information from various sources, such as electronic health records, clinical trials, and surveys. However, with such a sea of data, researchers can face many challenges with inconsistent data formats and mismatching fields. The number of ways we can go wrong is almost as vast as the data itself. Imagine walking into a supermarket and the fruit aisle displays bunches of bananas measured in ounces at one counter and pennyweights at the other. In fact, the UK only enforced the use of metric units for loose goods in the year 2000. In this video, we'll explore how data standardization is used to define and implement rules for collecting and formatting health data so that it can be used efficiently for research.
And then if we were to go to our CSS document, we can then refer to it in the following way. So when you create your own styles using the ID, you need to precede the name with a hash. So you use the hash symbol and then you write the name, your custom name for your element, and then you can provide additional styles as you see fit. So in this case, we're going to make the text color dark green as opposed to the dark blue color of the other paragraphs. And when we run that, you can see what it looks like here. So the standard paragraph here is in a dark blue still, but our sub-paragraph is now in dark green.
A signal such as Bluetooth is a really important inferred marker of socialization. So we're able to count the number of nearby devices and see how this changes in a day over the course of months and infer some health information from this. App usage is also a marker of socialization. So the amount of time we spend on apps such as WhatsApp and changes in these parameters, again, contain a lot of health information through inferred socialization. While mobile phone devices collect inferred information, we can collect more direct health information using wearables. For example, wearable devices measure a lot of different parameters to do with our sleep. The time we went to bed, how long we're in bed before we go to sleep, the different sleep stages we're in, what time we wake up. Changes again in these parameters can be used to infer a change in our health state. Heart rate information is a well-known physiological marker of health state and is easily collected using a wearable device that's on our wrist. We can also collect physiological information relating to activity. How many steps did we do in a day? How much time did we spend exercising? How heavy or light was this exercise? And again, it's changes in these parameters that can be used to infer changes in health state. What's really important to note here is that we're not interested in the change in one particular parameter, but looking for changes, looking for patterns over multiple parameters. A change in one parameter will lack specificity towards any one particular health state. For example, a change in heart rate variability is associated with a range of different health conditions.
Our aim is to shine a light on the most significant achievements of HDR UK affiliates in our mission to uniting the UK's health data and improving people's lives.